All right, hi everyone. This is the third video in our Module 19 review. And this math is going to be really similar to the previous video. It's just now we're using what we know about all of our angle relationships to prove that the lines are parallel in any given picture. Okay, so we don't already know they're parallel, we're going to prove they are. All right, so let's get started. Let's look at what kind of angles we have, and then we are going to either set them equal to each other or add them up to equal 180. Remember, that's really only our only two choices for these diagrams here, and let me make this a little clearer for you. Okay, so first I have this picture right here, and I've got these two angles which look to me like alternate interior angles. And so if these lines are parallel, these have to be equal. So I'm going to set them equal to each other. 10x minus 23. We're going to add 23 to 137 plus. So we get 160 equals 10x. And if I solve for x here, that's going to give me 16. Okay, so if these lines are parallel, then x would have to equal 16. And we know that using the converse of the alternate interior angles theorem. And that's all I'll write for that. Okay, next one, I have what looks like corresponding angles. So if these lines are parallel, we don't know yet, then these would have to be congruent or equal. So we're going to set them equal to each other. Okay, and I'm going to subtract 11 from both sides. So 74 minus 11 is going to give me 63. And if I divide that by 9, that's going to give me 7. So x has to equal 7 in order for these lines to be parallel, and that was using my corresponding angles postulate. I'm sorry, theorem. Okay. Next we have, all right, these two angles in here. These are going to be consecutive interior or same side interior. Okay, so they don't have to be equal for these lines to be parallel. They have to add up to 180 degrees. So I'm going to do that. Add them together, and they should equal 180. Let's see what x has to equal. So I'm going to combine like terms. So I've got 96 minus 30, that's 66. All right, then I'm going to subtract 66 from both sides. So that's 180 minus 66. And then I need to divide both sides by 6. So x is going to be 19 if those lines are parallel. And that was using my same side interior angles postulate. All right. In this picture, if these lines are parallel, then these would have to be congruent. Those are alternate exterior angles. So 33 equals 7x plus 5. So I need to subtract 5 from both sides of the equation. So I've got 33 minus 5. And if I divide both sides by 7, I get 4. So 4 is the x value that would make these lines parallel. And remember, that was my alternate exterior angles theorem. Okay, I'm going to do two more with you, and then I will give you the rest of the solutions. So number 5, all right, those are, again, corresponding angles. So if these lines are parallel, then these would have to be congruent. So I'm going to set them equal to each other. All right, let's isolate x. So I've got 3x on the left side, and I've got 19 plus 17 on the right side. And then if I divide 36 by 3, x has to equal 12 for those lines to be parallel. And that's using the converse of our corresponding angles theorem. All right, last one we're going to do together. These are same side or consecutive interior angles. So these, if these lines are parallel, have to add up to 180 degrees. So I'm going to do that. Plus 4x plus 1. Okay, we've got lots of terms to combine over here. So I've got 16x, and then I've got negative 28. All right, so I'm going to add 28 to both sides of the equation. So I've got 16x equals 208, and then I need to divide 208 by 16. So x has to equal 13. All right, so if those lines are parallel, then x has to be 13. All right, so if those add up to 180, we can say that the lines are parallel using our same side interior angles postulate. All right, so now's a great time to pause the video if you haven't done the last four. And if you're ready, here are the last four answers. So check your x value and check for the reasoning. Remember, we are using the converse of these theorems and postulates in order to say that the lines are parallel. Just a little trick on number 8, even though this angle was not measured with an angle, that symbol tells us it's 90. So I knew those two angles were 90. All right, moving on to the next page, or the back. We now have a diagram right here. Got a little cut off, but we do have 1, 2, 3, 4, 5, 6, 7, 8. So we've got all our angles accounted for, and we'll need this later. I'm going to label those M and N. Okay. So over here, all we're going to say is if lines M and N are parallel, then how do we know each one of these statements is true? So the first one is saying that 7 and 3 are congruent. Well, we know that by the alternate interior angles theorem. So just going through and seeing if we can remember all of our theorems and postulates. Next one, 7 and 6. Okay, it says they add up to 180. We know that using our consecutive, or same side, interior angles postulate. Okay, next statement, angle 2 is congruent to angle 4. Ooh, we know that using our corresponding angles theorem. And then the last one, angle 1 is congruent to angle 5. We know that's true because those are alternate exterior angles. So we use our alternate exterior angles theorem. Okay. We're still using the same diagram, might be a little off my paper, but you'll still have it on yours. We are going to say what the value of x is, and we're going to justify our answer. We know that M and N are parallel, so we already know that's true. All right, angle 3 and angle 1. Well, I know angle 3 and angle 1 are congruent, so that means I need to set them equal to each other. 15x plus 22 equals, okay, let's isolate our x. So we're going to add 10, we've got 32 on the left side. We're going to subtract 15, so that's 4x on the right. And we know 32 divided by 4 is 8. We used our corresponding angles theorem. All right, and the next problem is with angle 2 and 3. In that picture, those are same side interior. So I'm just going to already write that, same side interior angles postulate. So if that's true, then that means they're not equal, they add up to 180. So 5x plus 3, that's one of the angles, plus 8x minus 5, and they have to add up to 180. So let's combine like terms on the left side. So over here I have, what is this, 13x, and then we've got negative 2. All right, and then we're going to add 2, so I've got 13x equals 182, and if I divide 182 by 13, then x is 14. Just box my answers there. All right, last two, we are going to find the measure of the angles to make the lines parallel. So again, we don't know these lines are parallel, we're going to make them parallel. So first one, if 8 is 43 degrees, that's this angle right here, and 3 is the one we don't know, well, 8 and 3, Okay, so they're not going to be the same angle. 8 and 6 would be the same. That means that 3 would be the angle supplementary to that. So whatever 3 is has to add to 43 to equal 180. So 43 plus whatever angle 3 is has to equal 180. So I'm just going to do 180 minus 43. So the measure of angle 3 has to be 137 degrees in order to make those lines parallel. All right, this one we are given angle 7, that's this one right here, it's 95, and we want the measure of angle 6. Okay, so those are alternate interior angles, same side, I'm mixing up my words, same side interior, and that means they're supplementary. So 95 plus whatever angle 6 is has to equal 180. So I'm going to do 180 minus 95, and that leaves 85 degrees for the measure of angle 6. Okay, so those are my two answers for the bottom. Thanks so much for watching, guys. I've got 2 more videos, Module 19.4 and Module 19.5 coming up after this.